You might have seen this popular design before. This is 3D Flip menu, published by Minfam and Drupal. In this video, I describe how I implemented the design with Flutter. As you can see, the final result is very identical. Let's get into it. A few days ago, I was watching this video on Flutter YouTube channel. The presenter used this design as an example of complex UI and the aids of implementing it with Flutter, and disappointedly, he said,
"We will ignore the guitar, we will just focus on the drawer itself."
He's focusing on Flutter powers. Hence, ignoring this fabulous, amazing 3D object is a good practice. Flutter officially informed us there will be no 3D support in the near future. But I extremely enthused over bringing life to the concept. I mean a complete identical life. So I tried to find a workaround to implement similar designs. I will describe it and discuss about the pros and cons. Based on Marcin's advice, I started to analyze the design parts. It is structured with app bar which have a different direction, main content which includes a background, a 3D object, and an overlay. And finally, the drawer. Because of the part's behavior, I tear apart main content and put all the sections inside a stack widget. The order of the stack children is noticeable. The gesture detector will manage drawer interactions. Also, take attention to the stack overflow visibility. These are callback functions which I wrote for the gesture detector. The only thing I'm controlling here is the main animation controller based on the user touch behavior. The first widget I put inside the stack is responsible for rotation, background color, and fender world. The way I simulate 3D rotation is the one Marcin described with a little modification. For getting a responsible design, I try to position everything relatively to a screen size. Here, the max slide is a percentage of a screen width, which calculates in the widget lifecycle. The small number I added here is a very small degree in radians to improve perspective simulation. Without it, the front panel will rotate 90 degrees and appears as a line, but perspective wouldn't work like this. If a 3D object rotates 90 degrees in front of you, the far edge of side panels goes a little further inside. You can see this matter in our reference design. I added negative vertical position values to make a 3D cubic column rather than a box. I used another stack to position the word and a shadow to bevel it a little. At the end of the stack, that means the highest layer, I added an animated color to simulate light shading during rotation. Take attention to the way I use animated builder widget. I could probably wrap everything to a single giant animated builder, but it's not a good practice due to performance inefficiency, as it rebuilds every widget in every animation tick. The right way is to wrap static widgets inside the child input to let them bypass tick rebuilds. The next part I'm going to describe is the drawer. I positioned it to cover the screen with a relative empty space on right. Then I used opposite transformation to animate it from side to front. I've used an inner stack widget for two reasons: to animate a smooth edge with a thin 2D gradient, and to simulate light shading as we did for previous parts. Other parts are just to make a preview of drawer items. At this point, we have a great looking 3D rotation drawer, and we are ready to prepare our 3D object. As I mentioned earlier, Flutter doesn't support 3D objects, so I had to find a workaround. I've thought about using video, but soon after that, I realized video is not controllable enough and playing quality affects the final feeling. Then the idea of using frames as separate image came to my mind. This approach has been used for many years in various areas, like e-commerce websites, to give a 3D rotatable view of product. As always, I started to search for a similar Flutter package, and I found one called Flutter image-sequence-animator. It's exactly the thing I've sought. I used Blender to prepare the model and render a simple flip animation as separated PNGs. I searched for a free-to-use 3D model of Fender guitar. Found a few, but none of them was ready to use. So, if you want to reduce the time or you don't have enough 3D modeling and rendering knowledge, stick to the ones that aren't free. But I wanted to save a few bucks. I chose the free model that's missing some textures. I downloaded the free wood texture and applied to the guitar. Then I changed some materials to make the guitar looks better inside the app and make it more similar to the design. I created a linear simple animation during 120 frames just by rotating the model. I tried to position the origin similar to the rotation of the box. I choose linear timing curve because the user will control the rotation manually. Also, I used a proper HDR for the world. I used Cycle's render engine to get a smooth, best-looking result. An important thing to consider is enabling the transparency inside the render settings. These options and workflow are very similar between various 3D applications. In my laptop, it took about 40 minutes to finish the rendering. Now I have my PNG sequence, and I have to declare them as assets inside the YAML file. After configuring the image sequence package, I got this result. I realized that the package has a default color overlay and image sequence. Therefore, I had to modify it to fulfill my requirements. I removed default color overlay and make it possible to pass an external animation controller. I've sent a pull request to the author of the project. If it's been accepted at the time of watching this video, then happily use it. Otherwise, you have to do the same modifications or write your own widget. Here we go. We have a live controllable 3D object inside our app. Again, I've positioned the object relatively to make sure it appears the same on different screen sizes. Next part is the header. The widget is so simple, thus I wrapped everything inside the builder function. And finally, I wrote the overlay. The animation difference with the front panel is the extra translation I added to make it appear higher on the Z-axis. The final touch is adding a simulated shadow of guitar on the front panel. I did it by creating a stack contains two transparent container widgets with bluish shadow. Now it's time to inspect the usability of this workaround in real-life applications. I rendered the frames at the minimum resolution, which keeps the image quality sharp enough. 120 frames reach 20 megabytes. But I used a hilarious online tool called TinyPNG to optimize my images, and the total size reduced 70%. It just took 7 megabytes afterward. If you want to put just few objects in your app, it's reasonable to pack them within the installation. But for situations like product showcase, serving the image sequence on request is the wise decision. For sure, it's not as smooth as a native 3D API. Thank you for watching this tutorial. If you enjoyed, please like, subscribe, or turn on notifications to avoid missing future tutorials. You can get the complete project from the GitHub. I put the link in the description.